My name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 530. Please turn to it. Page 530, today's our lesson number 40. The two problems that you see in the second column, number 17 and 18, are the ones that we're going to do today. The two problems in the first column that you see, 15 and 16, are something that we already did yesterday on day number 39, in case you need help with them. Let's look at number 17. It's very important that you have the book in front of you so that you're able to read the problem on your own. Particularly this one, it's a tricky one. It says one end of an 80-inch long paper strip is shown in the picture above. So they're showing you here a strip of paper. It looks something like this, and then it goes something like this. And so on and so forth. So on and so forth. We are told the distance from here to here, this distance right here is 3 inches, this is 1 inch, this is 3 inches, this is 1 inch, and so forth. Again, 3 inches and 1 inch. The notched edge shown in bold. So shown in bold part is, this is what we're talking about. I'm going to show you in a different color. Right here. This is what they're talking about. The notched edge shown in bold, that's what they mean by bold, was formed by removing an equilateral triangle from the end of each 4-inch length on one edge of the paper strip as it is shown. Question simply is, what is the total length in inches of the bold notched edge of an 80-inch long paper strip? Now here's the deal with this. Listen, I went back and forth as to trying to figure out how to explain this problem. There is really not much in this problem if you understand it. There is not much of a mathematical solution. Here's what's going on. They're telling you that this equilateral triangle, that the notch that they're cutting here, they're telling us that it's an equilateral triangle. And this they tell us is 1 inch, which means this side is 1 inch and this is 1 inch. This side up here is 1 inch and this side up here is 1 inch. This part right you see there is 1 inch. This is 1 inch. So if you look at, instead of pretending, okay, here's what we're going to do. Instead of making it so complicated, I want you to change the problem and I want you to pretend that instead of 80-inch long paper strip, let's pretend that we have 8-inch long paper strip. 8-inch long. What happens? If we have an 8-inch long paper strip, we can actually draw the entire paper strip. It will look something like this. It will simply be an 8-inch long paper strip would be something like this. We will have 3 inches. Here's the 4th inch, 3 more inches, and the 4th inch. That's it. This is 1, 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 and this is 1. And this is 3. From here to here, from here to here is 3. So what's the length of the notch strip? It's very straightforward. All we are doing here is, listen, all we are doing is this. By cutting this notch like that, we are taking out this 1 inch, and then we are adding these 2 inches. That's all. So that 1 inch actually is taken out and instead of 2 inches put. So from here to here, now instead of saying here to here, I'm going to give them a name. A, B, C, D, and E. A to C, on the ordinary length would have been 4 inches. Would have been 4 inches, A to C. But because of the way it's cut here, from here to here is 3 inches, and then we have 2 more inches here. This part is taken out. This part is taken out here, and then we have 1 inch here and a 1 inch here. So the 3 inch becomes this 1 inch becomes 2 inches because we're measuring this length. This is 3, 4, and 5. You see, 3, 4, and 5. Again, 3, 4, and 5. So what do we find? What we find is that an 8-inch long paper strip now is counted in terms of its length. In the notched part of it, it's counted as 10 inches. It's counted as 10 inches. This is 3 inches, 4, 5, 6, 7, 8, 9, and 10. There you go. And this is an 8-inch strip. An 8-inch strip on 8-inch strip has 2 segments, each 5 inches. That's it. The question is, the point here is that we don't have an 8-inch long strip, we have an 80-inch long strip. An 80-inch long strip will have how many segments? Well, each segment actually is here to here, which is 4 inches, out of which we take 1 inch and we cut it in this. But segment itself is this 4 inches here. So 80-inch strip, an 80-inch strip will have 80 divided by 4, or 80 divided by 4, or 20 strips, 20 segments rather, 20 segments. And each segment is 5 inch long. Each segment is 5 inch long. And we have 20 segments. Where do we get 20 segments? That comes from the fact that it's 80 divided by 4 is 20 segments. And each segment is 5 inch long. Therefore, the total length of the notched edge will be 5 times 20, or 100 inches. That's it. That's it. Each segment is 5 inches long, and therefore, since we have 20 segments, it will be 100 inches. And that's all there is actually. There's not much of a solution that I can show you here. That's all. There was one more thing I wanted to talk about, and now I'm trying to figure out what it was. I had it in my mind a second ago. So that's about it. That's it. And this is how one segment looks like. This one segment looks like this. From here to here is 3 inches, and then 4 inches, and then 5 inches. That's the end of, this is what I'm calling the segment. Ordinarily, it would have been 4 inches. Ordinarily, this would have been 3 inches, this would have been 1 inches. So a segment is 4 inch long. This is what I'm calling a segment. A segment is 4 inches long, but in terms of its notched length, it's counted as 3, 4, and 5. 3, 4, and 5. Now, how do we know? How do we know that from here to here is 1 inch? Because they're telling us that the triangle that we're cutting is an equilateral triangle. And since this distance is 1, therefore this distance is 1 and this is 1. That's all it is. I don't want to keep explaining the same thing over and over again. But as I told you, in terms of mathematical solution, there is not much there. You just have to understand the wording of the problem, and that's what's going to throw off a lot of people. I myself had to read it at least 3 times before I actually understood it. The first time, of course, you just read it, and then the second time I read it one more time, and I sort of got it, and the third time when I read it, it began to sink in. And that's what it was. That's it, we're done with this one. Let's move on to the last one. Let's move on to the last one. Number 18, the very last one. Number 18, they gave us a parabola that looks something like this, and we are told that it is sitting in a square, is it? And the picture above PQRS is a square, so it is a square. I have to make sure that I draw it as a square. It has to look like a square. So let's pretend that this looks like a square. There you go, it's a square. This is P, Q, R, and S. Okay, let's see what happens here. It's a parabola. It has an equation we are told is equal to ax squared, where a is a constant, of course, and we are told that the area of the square is 64 inches. That's the most important part here. Area of the square is 64 inches. If the area of the square PQRS is 64 inches, 64 square inches rather, area cannot be inches, it has to be square inches. If it's 64 square inches, that implies that each side must be 8 inches. So P to Q, that implies that P to Q is 8. And of course, so is Q to R, and so is P to Q is 8 inches, so is Q to R, and so is R to S, and so is S to P. And they are all 8 inches. Now what does this actually tell us? It tells us that the coordinate, this tells us that the coordinates of point R are the point R right here. The x coordinate, watch for here, because it's a square and sitting symmetrically, which means this distance from P to let's call it P to Y here. This distance right here is 4. I'm not going to give it a name, that'll be silly, because Y is the Y-axis. And this distance from here to here is 4. Which means coordinates of points R are going to be, the x coordinate is going to be 4, and the y coordinate is going to be 8. 4 and 8. We are almost there. 4 and 8. Now, all we have to do is substitute these two coordinates in the equation of the parabola, because the parabola goes through this line here, it goes through point 8, which means the coordinates of the point R must satisfy the equation of the parabola. We substitute the coordinates of x and y in the equation of the parabola, and we solve for our constant a. That's all. Let's do it up here. Our equation of the parabola, we are told, is y equals ax squared, and because it goes through point R, which is 4, 8, a times 4 squared, we substitute in place of x, we substitute 4 for x coordinate and 8 for y coordinates. And that equation should hold. That equation should be satisfied because of the fact that that's the equation of the parabola, and we know for a fact that it goes through point 4, 8. It also, of course, goes through point negative 4, 8. We could have put that in there too. Nothing would have changed. In which case, we would have been using the coordinates of point Q. The coordinates of point Q are negative 4 and 8. How do we know this is 4? Because it's half the distance from here to here. From P to S, is 8, and therefore this is 4 and this is 4. So that's it. So even if we had used the coordinates of point Q, nothing would have changed. We simply would have had negative 4 in there, and negative 4 squared, of course, the same as positive 4 squared. So that's it. We just have to solve for it. So 8 equals 16a, and therefore a equals 8 divided by 16, or 1/2. That's it. 8 divided by 16, or a equals 1/2. That's our answer. That's our answer. That's it. We're done. That's what they're looking for. They're looking for the value of the constant a. That was the end of this section, section number 5. We have still one more section to go before we finish the third exam, and we'll just keep on going. Do you understand? So I'll see you on day number 41. We'll begin our new section. Okay? Bye now.